from the book and talk. Okay, like I just said, we're going to deviate from the book, and we're going to title this section LA, which stands for lateral area, and SA, which stands for surface area of prisms and cylinders. All right, so what we want, remember a prism, I'm just going to draw a triangular prism here. I'm going to lay it down on its side. A little bit easier to draw, I think. So this is a triangular prism. Because bases are triangles. There are two of them making it a prism. The lateral faces all of the sides that are not bases. So it's all sides that are not bases. So in this case, it would be the three rectangles. A right prism, just getting some vocabulary out of the way here, means when I stand it up. So if I was to stand it up so the triangle was down, like the triangle are the feet and the other triangle is the head, if that makes a right angle with the ground, that's a right prism. So the sides are rectangles in that case. If it's leaning when you, like the Leaning Tower of Pisa there, if it's leaning, it's a prism. An oblique prism has parallelogram sides, not rectangles. At least a parallelogram that's not a rectangle. And then the altitude is the perpendicular distance between the bases. So it's the height of the prism. So in this case, even though I've got this laying down, the height is not the top to the bottom here, but it's how far apart these are. That's your height. So when I stand it up tall, it would be the height. That would be the height. So even though it's laying down, that's still the height. The distance from the triangle to the triangle is always the height. All right. So what we're going to be doing today, like I said earlier, is finding lateral area and surface area. Well, this lateral area ties back to the lateral faces. So we are going to do our first example. We're going to do it the long way, and then we're going to streamline it with a formula. So if I take this prism right here, that had three rectangles. Three rectangles. I'm going to make it not equilateral. Make it isosceles. And then it had the two triangle bases. So in essence, when this folded up, I didn't make it perfect, but this side would land on this side. Those should have been the exact same length. I didn't do the best job there. This side and this side would touch when it folds. And then, so let's say this distance is 4. And let's say this across here was 5. So if we were going to find the lateral area, is the area of the lateral faces only. So in this case, it would be the area of the three rectangles. So the LA here would be rectangle plus rectangle plus rectangle. BH plus BH plus BH. Just the rectangle. So this first rectangle is a 4 by 5. This middle rectangle is, oh, I didn't give you that. No, that's not 5. I want that to be 6. 6 all the way across there. 6, 4 by 6. This middle one is 5 by 6. Oops, I'm not on the screen. Sorry about that. Let you catch up. So I did this rectangle as a 4 by 6. This one's a 5 by 6, and there's another 4 by 6. So that's 24 plus 30 plus 24. Lateral area of 30, 40, 50, 60, 68. Okay, now surface. So lateral area, our surface area would be the lateral area plus your two bases. And that's the area of the two bases. And remember, in a prism, that base shape can change. In this case, it's triangles. So for us, we've already found the lateral area. We're not going to redo all that work again. We're just going to substitute in the 78. Plus, for this one, it's two triangles. I'm going to take an extra step here. And the area of just one triangle is base times height divided by 2. And you can see those 2's are going to end up canceling each other out. So look at the triangle and see if I can find the base and the height there. If we go back, I just focus on one triangle. I can see the base is 5. This outside edge is 4, but that's not the height. The height comes down the middle here. The height of the actual triangle, which is what I'm focused on, not the height of the prism. I need that to find this area. So the only way I'm going to find that is a little Pythagorean theorem. If I look at this right triangle, I've got a 4 here. The whole side was 5. That means this is 2.5. So now I can Pythag it with leg squared plus leg squared equals hypotenuse squared to get that value. All right, so it's 2.5 squared. Sorry, plus h squared equals 4 squared. So if I do all the work here, I can do this on one line. So 4 squared, subtract 2.5 squared, and square root that. The height is about 3.12. So I didn't show any work here. We're at the end of the year. You should be good with a calculator at this point. Now I can come down here and finish this up. 78 plus 2. Base is 5. The height we just calculated as 3.12. Divide by 2. I can cancel the 2's out. So 78 plus 5 times 3.12. 93.6 is our surface area. Now, we can streamline this slightly by this up here, this base times height, base times height, base times height. If you look, the one number that stayed consistent all the way through these 3 rectangles was that 6. That height value never changes. But the base does change as I move around the base of that triangle here. We had a 5, 4, and 4. That does change, but the height of that rectangle never changes. So if you look at what happened here, if I take the 6 out of these, you don't have to write this on your paper. I'm just going to show you real quick. Take the 6 out. What I've got is a 4 plus a 5 plus a 4 again. that's essentially just the perimeter of that base. So we do get a nice formula for lateral area of a prism. The LA for a prism is the perimeter of the base multiplied by the height of the prism. Those two numbers multiplied together will do all of the individual rectangular areas and add them together all at once. So our formula we're going to use is LA equals PH. Then for SA, we're going to say that's the lateral area plus the area of two bases. So two base areas. And because the base shape can change from a triangle to a square to a hexagon to anything, we can't put a formula there. So we just say it's LA plus 2 of our big B's. And know that big B stands for the area of the base. So I have those two formulas added to my note card for prism. I drew a prism here. I put big B to represent the area of the base, the height to represent the height of the prism. So it's perimeter of the base times the height of the prism for LA. SA is that value plus 2 base areas. So I've got that all set. You can add that to your note card. You should have all your other formulas on top. Again, my paper's at school, I'm at home. So we're going to use those shortcuts to do a couple more examples together. Let's go. Let's do number 1. What was that? Did I call that last one an example? I did 2. Let's take this 1, 2, 3, 4, 5, 6. Prism. I'm not going to draw all the hidden lines. So, and here's what we know. We've got 10 and 6, and it's a regular hexagon all the way around. Regular. So, yeah, let's find lateral area and surface area. So the lateral area for a prism is just PH. Remember, P is perimeter of the base, height of the prism. So the perimeter of the base is just 6 sides of 6. So the perimeter is 6 times 6 for 36. I'll just do that off to the side. The height of the prism is 10. Because remember, all we're doing is 6 times 10 to get the area of one of these and then adding them all together, which is 6 of them. So we will get 360 for the lateral area. Now here's where the work comes in. Surface area is LA plus 2 base areas. Well, we've already done the work there. I'm just going to substitute 360. The base is a regular hexagon. Look back at your note card, and I've got 2 of them. A regular hexagon is 1/2 apothem times perimeter. So we've got to do a little bit of work to get that apothem value. So let's go back over the picture and work on that apothem. Remember, the apothem goes from the center to the midpoint. We need to figure that out. So if I draw in this isosceles triangle, what I know is this side is going to be 3. I'm going to find the angle here by taking 360, first just dividing it by 6, because I would have 6 of those isosceles triangles. So each full angle in 60 degrees. Cutting that in half, we've got a 30-degree angle. So then we can find the apothem that we were looking for by using, well, we got a 30, 60, 90 here. We can use the shortcut, or we can use trig. I think I'm going to go with the shortcut. If the short leg is 3, the long leg, you multiply by the square root of 3. So the apothem will be 3 square root of 3, or if you can't remember that ratio of those sides, because it's 1, hypotenuse is double, long leg is times square root, always use trig. And I'm not going to do it all the way through, but the tangent of 30 would equal opposite over adjacent. So opposite would be the 3, adjacent would be the apothem, and you could do cross products and come up with an equivalent value here. Okay, we're just about ready. So 360 plus, I'm just going to cancel these out and worry about them. 2 gets multiplied by a half, that goes down to 1. So the apothem is 10 square root of 3. The perimeter, it's the same perimeter we had before, 36. And now calculator. 360 plus 10 square root of 3. No, get out of there. Times 36. I got 983.54. Okay. All right. The other shape we're doing today is that cylinder, and it's almost easier than this. So cylinders. Get rid of that. I need more room here. Cylinder. And remember what the net looks like. It's a rectangle with the 2 circles. Okay, the lateral area is going to be the area of this rectangle. Remember, any rectangle is base times height. Well, the height of the rectangle is the height of the cylinder. But this distance here, think about this. That distance along there wraps around this circle. Think about this rectangle right here. If I want to curl this into a cylinder, that straight edge wraps around the circle. The distance around a circle is called circumference. So this right here, this base of the rectangle is equal to the circumference of a circle. And if you remember the circumference of a circle, that's just pi times diameter. So to get the area of this rectangle, it's pi d, because that's the base, and the height is h. So the LA formula for a cylinder is just pi d h, pi d8. That will get you the area of the rectangle. Surface area now. Well, you take the area of the side. Get on the screen here. Plus, you're going to add 2 circles. And every time on a cylinder, those are circles. And the area of each one of those is pi r squared. And we've got 2 of them. That's why the 2 is there. So, that was bad. 2 pi r squared. So, on my note card, I did add those 2 formulas over here, showing the radius of the circle, the h, the lateral area is pi dh, surface area is that, plus the 2 circles, 2 pi r squared. So let's take a look at one of these and we will be done. So number 3. Let's go cylinder. Oops, that was bad. Let's go 5, 2, LA and SA. LA is pi dh. Write out the formula first. D is diameter of the circle. I did give you that value. That's 2. H is height of the prism. Give you that. That's 5. So LA is 10 pi. I'm not going to pick up a calculator. I'm going to leave it at that. SA is that LA, well, do formula first, plus 2 pi r squared. So substitute in the 10 pi. Now the radius, if I look back, is 1. And 1 gives me that diameter of 2. So that's going to be 10 pi plus 1 squared is 1. Multiplied by 2 is 2. 2 pi. 2 pi gives me a total of 12 pi. And there it is. So you'll be showing formulas and show work today on homework, but it's not bad if you take your time and write stuff down.